Hi there everyone, and welcome to my shop, Redline Tuning in Port Shepstone. Today I'm going to explain to you what is dyno tuning. Dyno tuning is basically measuring the power of the vehicle and then making modifications or alterations to the car's tuning, the intake or exhaust system in order to get more power. So in order to know whether your power levels are going up or down, we use a machine called a dynamometer to measure the power of the engine at the wheels. So let me show you how it works. Basically, we have a computer system that is linked up to these rollers on the floor here. And there is a device on here called a load cell, which measures the amount of load going on our motor on the dyno rollers. So basically, as you accelerate, the force that it turns the roller, that is how it measures the power that the car is making, and it translates it into a graph on the computer. So let me show you. I've got a car that hasn't been here before. We're going to strap it down, we're going to load it into the computer, and I'll show you exactly how we try to find a little bit more power out of this Opel Corsa DSI. Okay, so first of all, we need to create a vehicle. If it will allow us to create a new vehicle. There we go. Okay. Usually here we'd use the number plate, which is in Okay, so basically now we've entered the vehicle's information into the computer. Now we need to determine the gear ratio as per which gear I'm using on the car, so translate that the dials on the computer are the same as the dials inside the car. So I'll use my handheld controller. I'll enter the target gears in there, and the computer will automatically detect once I get to 3000 RPM and press the button what the actual ratio is. So in these tests, I normally use 4th gear. So now I'm going to do the gearing, and you can see how I log the button in order to calculate. So I'll use the calculate button here. Okay. Now I'll use my remote. Basically now, we are just getting it up to the 4th gear and getting it to the 3000 RPM mark. And you can see on the computer there how it's reading the speed. So now the computer's calculated the gearing. Let me go into the test parameters. Okay, so what we're going to do now is we're going to enter the test details, and we're going to put in the start RPM and the end RPM, basically where you want it to start plotting the map and where you want it to start ending the plotting. So this will be test 01. And then usually we'll start at about 2000 RPM, and the red line on this car is probably at 6000, so we'll put it to 5800. Alright, now we will do the run, and it will measure the power and give us a graphical display on the screen. Okay, so we've done a run, let's see what power it makes. Okay, the power that this car made, bearing in mind, a GSI I think is a 1.8 in this model, so it made, just 1 second. Okay. At the peak point it made 73 kilowatts and 164 Newton meters of torque. So that's about fair for this engine. If I look at the factory spec, it probably makes about 72 to 75 kilowatts on the engine. So you would generally have a 15 to 20% loss from the engine kilowatts to the wheel kilowatts. So always keep that in mind. Okay, now what we're going to do is now we're going to see if we can find any extra power in the car. So usually on a car like this, the air filter might give some restriction. So what we would normally do now is remove the intake pipe and do another run and see if the car gains more power. Then we know that if it's breathing better, we can improve the intake system. Okay. Please bring me a flat screwdriver.
Action.
Alright, so I have basically opened the intake pipe and now we'll do another run and we'll see if the car gains any power. Okay, so you can see it did gain a significant amount of power. If you look at the graph, you can see all of this is gains. So we basically went from 72 kilowatts up to 80 kilowatts. So it's an extra 8 kilowatts that you can gain just on doing a modification to either the air box or your air intake system. So the next thing we're going to check is just the fueling of the car. So we're going to put a probe in the exhaust and I'm going to check the actual air fuel ratio to make sure that the car has got the correct air and fuel mixture. And then the last thing we'll do after that is just to plug in the machine to run a diagnostic to see if there are any electronic faults present on the car's ECU.
Action.
Alright, so what I've done now is I have switched on the fan. Now I'm going to load the vehicle, which means I'm going to drive it, and then I use the dyno to actually put load on the engine. Then I can accelerate fully and the car RPM won't pick up. That's how I can check the fuel mixture between light throttle and full throttle at the various RPMs, as I can lock it with the dyno software and it will keep it at a constant RPM. And then I've plugged in the diagnostic machine just to see if there's any faults in the car's ECU. Okay, so what we're starting with is the diagnostic first. Just to make sure there's no ECU faults that will be robbing the car of any power. There, it's not showing any fault code on the car's ECU. Okay, so so basically now I'm going to use the load function on the dyno, and you can watch the fuel mixture on the gauge across there as it leans out. As you can see, I'm holding it on the dyno. I can control the RPM down. If you look on the gauge across there, you can see the fuel mixture. 14.7 is a perfect mixture. Usually you would want it 14.7 to 15. You can see it's in the correct range. And then if I increase the throttle, you can see it's still quite lean low down. And then I can go up with the RPM. And then we can see. So you can see it's dropping down to a 12.9. And that is just about the right mixture for a car like this at full throttle. So if we had a mixture of anywhere in the 15s at full throttle, we would know that the car is lean. Then I would start to look at things like the fuel pump and the fuel supply. But as you can see, the power is sort of where it should be. There's no lean condition. We found already that just by modifying the intake flow, we're going to gain about 8 kilowatts. I've also subsequently found that the accelerator cable wasn't adjusted correctly. So let's just do one more run and we'll see if it makes any extra power with the adjustment of the cable. Okay, so this is the final test, and now we'll see what we've done and how much power we've gained extra on this car. Just film me by the dyno computer. Even more power just with an adjustment on the throttle. So as you can see, before we were on 80 kilowatts and we went up now to 91 kilowatts, and the torque was at 167. Now we've got it up to 184. So it's amazing, just a few small tweaks and we have gained probably almost 20 kilowatts. Let me load the other tests. You can see exactly test one.
Owie.
So there you can see, this is the improvement without any actual tuning. This is just with intake modifications and just adjusting the accelerator cable. As you can see, it started out at 73 kilowatts and 165 Newton meters, and it went up to 91 kilowatts and 185 Newton meters. So you can see that is quite a substantial increase. So you can see how dyno tuning does help, because you wouldn't have felt that on the street, but we can prove it on the dyno. So if you've got a car that's feeling a bit sluggish, you want a bit more power, you want to modify it, you want to put a branch on, you want to do an intake, come and do a run first. Then you know where the power is, and then any modifications you do from that point, you can see that the power goes up or down. because let me tell you, some conversions do make the power go down, so just beware. Right, so thank you so much for watching, and I hope you enjoyed this little video on what a dyno tune actually does. And if you want any sort of tuning advice, give me a call on 039 68 22 881. Redline out.